तो मैथमेटिकली वर्क एनर्जी थ्योरम is work done by all forces equal to change in kinetic energy delta K, या इसको मैं ऐसे लिख सकता हूं KF final kinetic energy minus initial kinetic energy. This is change in kinetic energy. This is change in kinetic energy. KF minus KI. या ऐसे final kinetic energy 1 by 2 mv square minus 1 by 2 mu square. This is the most beautiful equation because this equation is used for all types of forces. Either forces are conservative, non-conservative, internal or external. अब देखिए, अब अगर मैं आपको बोलूं ये वर्क जो है ये वर्क पॉजिटिव कब होगा, वर्क पॉजिटिव कब होगा? अब देखिए ये जो KF है ये पॉजिटिव टर्म है, तो if KF is greater than KI, अगर फाइनल काइनेटिक एनर्जी ज्यादा होगा एज कंपेयर टू इनिशियल काइनेटिक एनर्जी, वर्क डन बाय फोर्स, वर्क डन बाय फोर्स इज पॉजिटिव. तो उस केस में वर्क डन जो होगा वो पॉजिटिव होगा. तो लेट मी एक्सप्लेन दिस. इफ KF, if अगर फाइनल काइनेटिक एनर्जी ज्यादा होगी एज कंपेयर टू इनिशियल काइनेटिक एनर्जी, तो वर्क डन बाय फोर्स इज पॉजिटिव. Work done by force is positive. Consider here a block of mass m. Let the velocity of this block at this point be v in forward direction, in this direction. Now, if force is acting on this object along the direction of velocity, along this direction, means the velocity of the particle is along this direction, the force on this object is acting along the direction of velocity. You know, when force is acting on the object along the direction of the velocity of the object, the magnitude of velocity increases. The magnitude of velocity increases. तो यहाँ पे जो इस object की velocity होगी, let that velocity be v dash. तो ये velocity जो होगी, ये velocity v dash is greater than v. अगर मैग्नीट्यूड ऑफ वेलोसिटी यहाँ पे ज्यादा है एज कंपेयर टू दिस v, तो इसका मतलब यू नो काइनेटिक एनर्जी जो होता है वो होता है 1 by 2 mv स्क्वायर. व्हाट इज दिस v? v इज द स्पीड. नो हियर यहाँ पे क्या हो रहा है, यहाँ पे फोर्स जो एक्ट हो रहा है पार्टिकल पे, दैट इज एक्टिंग अलोंग द डायरेक्शन ऑफ वेलोसिटी. तो व्हेन फोर्स इज एक्टिंग अलोंग द डायरेक्शन ऑफ वेलोसिटी, द मैग्नीट्यूड ऑफ वेलोसिटी इंक्रीजेस. If magnitude of velocity increases, it means that speed of the particle increases. If speed of the particle increases, it means that kinetic energy of the particle increases. तो इस केस में जो यहाँ पे let this kinetic energy be KF and यहाँ भी KI. तो इस केस में जो final kinetic energy है वो ज्यादा है as compared to initial kinetic energy से. तो it means that work done by this force on this object is positive. तो work done is positive. तो इसका मतलब हुआ ना, when force acting on a particle increases the kinetic energy of the particle, the work done by the force on the particle or object is positive. अब case number second. Now, ये जो वर्क है, वर्क इज इक्वल टू KF माइनस KI. अब अगर ये इनिशियल काइनेटिक एनर्जी अगर ज्यादा होगी, KI इज ग्रेटर देन KF, तो उस केस में जो वर्क होगा वो होगा नेगेटिव. वर्क क्या होगा इस केस में? नेगेटिव. तो लेट मी एक्सप्लेन. इफ हियर इज अ ब्लॉक ऑफ मास m, let the velocity of this block at this point be v, and on this block a force F is acting opposite to the direction of velocity. And you know, when force is acting on a block in a direction opposite to the direction of velocity, the magnitude of velocity decreases or the speed of the particle decreases. So if speed of the particle decreases, let here the speed of the particle be v dash. Now force is acting in a direction opposite to the velocity of the particle. It means that this v is greater than v dash. तो v is greater than v dash. तो इसका मतलब हुआ अगर यहाँ पे स्पीड ज्यादा है पार्टिकल की, तो इसका मतलब जो यहाँ पे काइनेटिक एनर्जी होगी लेट दैट बी KI. और यहाँ पे काइनेटिक एनर्जी kF। तो इस केस में क्या होगा, स्पीड यहाँ पे v जो है, ये जो यहाँ पे जो स्पीड है वो ज्यादा है एज कंपेयर टू दिस स्पीड, तो इसका मतलब जो यहाँ पे काइनेटिक एनर्जी है वो ज्यादा होगी एज कंपेयर टू दिस काइनेटिक एनर्जी। तो ki is greater than kF, it means that work done by this force on this object is negative. So it means that work done by force on the particle is negative. If force acting on the particle decreases the kinetic energy of the particle or speed of the particle. Decreases the kinetic energy of the particle or speed of the particle. Now, अब अगर force, if force is perpendicular to the velocity of the particle, you know when force is perpendicular to the velocity of the particle, then only the direction of velocity changes. The magnitude of velocity remains constant. The magnitude of velocity remains constant. Like in case of uniform circular motion. In case of uniform circular motion, where there is only one force, that is centripetal force. That centripetal force is perpendicular to the velocity of the particle at every point. So hence the centripetal force changes only the direction of velocity, not magnitude. Not magnitude. तो हमेशा याद रखना, whenever a force is acting perpendicular to the velocity of the particle, then force changes only the direction of the velocity, not magnitude. तो magnitude of velocity remains constant or speed of the particle remains constant. If speed of the particle remains constant, it means that kinetic energy of the particle remains constant. If kinetic energy of the particle remains constant, it means that change in kinetic energy is zero. If change in kinetic energy is zero, it means that work done by this force that is perpendicular to velocity is always equal to zero. So that is why work done by centripetal force is always equal to zero. That is necessary, that is secondary question, that this centripetal force is not a new kind of force. It is being provided by some external agents, like Earth is revolving around the sun. There is the gravitational force that provides that centripetal force. Or an electron is revolving around the nucleus. There is an electrostatic force that provides that centripetal force. और यहाँ तो आपने मैग्नेटिज्म में पढ़ा होगा, when a charged particle Q is projected with velocity v in a magnetic field, the force acting on the charged particle in a magnetic field is given by this equation, the magnetic force Q v cross b. This magnetic force is perpendicular to the velocity of the particle as well as magnetic field. But यहाँ पे this magnetic force is perpendicular to the velocity of the particle. Since this magnetic force is perpendicular to the velocity of the particle, it means that it will not change the magnitude of velocity. If it not change the magnitude of velocity, it means that it will not change the speed of the particle. If it will not change the speed of the particle, it means that it will not change the kinetic energy of the particle. Hence, work done by magnetic force on the charged particle is always equal to zero. So now let me show you basic examples from motion and gravity, then we will follow numericals. ये जो है आपने पढ़ा होगा motion and gravity में, an object is dropped from height h. You have to find the velocity with which it hits the ground. You have to find the velocity with which it hits the ground. तो कैसे देखो, आपने तो निकाला होगा by using the equations of motion, but I will find the same by using work energy theorem. So first of all, you know, by work energy theorem, work done by all force equal to change in kinetic energy. We have to show the forces that are acting on this ball. Let the mass of the ball be m. The force that is acting on the ball is mg in downward direction, and we can neglect here air resistance. The only force that is acting on this ball is this mg. Now what is the work done by this mg? As this mg is constant through this small distance, the work done जो आएगी by this mg, that is, you know, work done by constant force is Fs cos theta is equal to change in kinetic energy. Final is 1 by 2 mv square. Force mg s h. This theta is the angle between F and S. mg in downward direction, h in downward direction, so cos theta आएगा 0, cos 0 is 1, so that is equal to 1 by 2 mv square. m gets cancelled, it is 2gh is equal to v square. तो v आएगा आपका root of 2g. This is the velocity with which it hits the ground. या तो आपने motion under gravity में ये भी देखा होगा, when an object is projected upwards with velocity u, you have to find the maximum height attained by the attended by this particle. Let the maximum height attended by this particle be h. So, what are the forces that are acting on this ball? That is simply, if the mass of this ball is m, mg in downward direction. What is work done by this mg? Mg in downward direction, h in upward direction. So work done by this mg is negative on the object as two are pointing in opposite direction. So minus mgh is equal to, this is work done by mg. Change in kinetic energy. Final kinetic energy is 0 minus initial 1 by 2 mu square. M gets cancelled, so minus minus gets cancelled. It is gh is equal to u square by 2. So h आएगा आपका u square by 2g. This is the maximum height attained by the particle. Now we will start solving some problems. So first of all, we will drop this. Question number 1. Question number 1. If the surface, and on this surface a block of mass m is placed. A block of mass m is here, and the speed of this block here is v. The coefficient of friction between the two surfaces is mu. The velocity of this block decreases. At this point, the velocity of this object becomes 0. You have to find the distance traveled by this block before it stops. Let that distance be s. You can find this stopping distance by using the third equation of motion theory. You have to use the concept of frictional acceleration. But I will find the same by using work energy theorem. So first of all, you have to show what are the forces that are acting on this block. That is mg in downward direction, normal reaction in upward direction, and third is frictional force in this direction. The work done by this normal reaction and mg is 0 because both these forces are perpendicular to this length. The only force that is doing work on this object is this frictional force. So what is the work done? And this frictional force is acting in a direction opposite to the direction of velocity. Therefore, the work done by this frictional force on the object is negative, and therefore the velocity of the object decreases, and finally it becomes 0 here. Now, work done by frictional force is equal to change in kinetic energy. What is work done by this frictional force? In this direction, frictional force in this direction, displacement in this. So work done by frictional force आएगा minus Fs, change in kinetic energy. Finally 0 minus initial 1 by 2 mv square. So यह आएगा minus Fs is equal to minus 1 by 2 mv square. Now frictional force, आपने friction में पढ़ा होगा, frictional force होता है mu into normal reaction, और यहाँ पे जो nature है frictional force का is kinetic. तो frictional force जो है is equal to mu into m. अब m कितना है? देखिए, as there is no acceleration in this direction, in y direction, in this direction, so it means that net force along this direction is 0, and this is possible only when this normal reaction is equal to mg. तो m के बदले वैल्यू को यहाँ पे mg, तो mu mg, this is frictional force. तो minus minus cancel होगा, minus minus, तो frictional force mu mgs is equal to 1 by 2 mv square. mm gets cancelled, s is equal to v square by 2s mu g. This is the stopping distance. S is equal to v square by 2 mu g. Now, question number 2. Question number 2. Question number 2. Here is a surface. On this surface, a block of mass m is having a velocity v at this point. The coefficient of friction between the two surfaces p mu. The velocity of this block becomes v by 2 after traveling a distance d. After traveling a distance d, we have to find work done by frictional force over this distance, and second, find coefficient of friction between the two surfaces. You have to find the work done by frictional force and this coefficient of friction. तो यहाँ पे भी आप वही what you have to find. देखिए, first of all you have to show what are the forces that are acting on this block, that is N, mg, but these forces are not doing work on this object. Hence, तो यहाँ पे जो A की force जो इस object पे काम कर रहा है, that is frictional force. तो you have to find the work done by frictional force. Simple है, work done by frictional force हमें निकालना है, that is simply equal to change in kinetic energy of the block. तो 1 by 2 mass of the block, final speed, that is v square, this square. तो ये बनेगा v square by 4 initial square. तो v square. तो ये आएगा 1 by 2 m minus 3v square by 4. तो ये आएगा minus 3m v square by 8. This is work done by frictional force. 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 हो गया ये first part. अब second, we have to find the coefficient of friction. तो अब देखिए work done by friction कितना आया हमारा? वो आया हमारा minus 3mv square by 8. But you know work done by frictional force over this distance d is minus mu mgd is equal to minus 3mv square by 8. Minus minus m. तो mu आएगा आपका 3v square by 8 gd. This is the coefficient of friction between the two surfaces. Question number third. Question number third. 3. Here is an inclined plane. This is an inclined plane. The angle of inclination is theta. And object starts from this point. From this point A. Since the object starts from rest, so it means that यहाँ पे जो इसकी initial velocity है, that is 0. The length of this plane is L. It is given that first half of this plane is smooth, means A से लेके B तक. Half, तो it means that ये होगा यहाँ से लेके L by 2 is smooth. Smooth का मतलब हुआ there is no frictional force between the two surfaces, or there is no frictional force acting on the block. And the next half of this plane is rough. Is rough तो means यहाँ पे जो है, जब यहाँ पे block होता है, and the coefficient of friction between the two surfaces is mu. And finally the object stops here. Question 3 से देखिए. This is an inclined plane. The angle of inclination is theta. The length of this plane is L. And object starts from rest and from this point A. The first half of this plane is smooth, means there is no friction, and the next half is rough. The coefficient of friction between the two surfaces is mu. And finally the object stops here. We have to find mu. Find coefficient of friction between the two surfaces. Find mu. तो कैसे निकालोगे आप? देखिए, the force that's acting on the particle, on this object, between A and B is mg in downward direction. This mg can be resolved into two components. This is mg sin theta and this is mg cos theta. तो यहाँ पे normal reaction है ऐसे. अब देखिए ये जो normal reaction है and this component of mg, these two forces are perpendicular to this length. Hence the work done by this end and mg cos theta is 0. The only force that is doing work on this block from A to B is this mg sin theta. But जब यहाँ पे block होता है, from B to इस area में B से लेके C तक, तब तो दो forces इस object पे काम कर रहे हैं. एक तो mg sin theta और दूसरा frictional force इस पे होता है ऐसे. Now, अब apply work energy theorem. Work done by frictional force plus work done by gravitational force is equal to change in kinetic energy. अब यहाँ पे finally object stop हो रहा है, तो इसका मतलब यहाँ पे kinetic energy 0. Initially the particle starts from rest, तो यहाँ पे kinetic energy 0. 0 minus 0, that is 0. Now what is work done by frictional force? अब देखिए, frictional force जो है, work done by frictional force is, अब frictional force act हो रहा है only over this distance. So how much frictional force? That is F. F is in this direction and L by 2 is in this direction. So it means that work done by this frictional force on the object is negative. How much? Minus F L by 2. Plus work done by gravity. What is work done by gravity? mg sin theta into this L. mg sin theta into L is equal to 0. Now ये फ्रिक्शनल फोर्स कितना होता है इनक्लाइंड प्लेन में? आपको पता है जो फ्रिक्शनल फोर्स होता है that is equal to mu n. अब यहाँ पे mu n कितना होता है? n is equal to mg cos theta. तो फ्रिक्शनल फोर्स काइनेटिक फ्रिक्शन mu mg cos theta. तो इसके बदले ये सब्स्टिट्यूट कीजिए माइनस mu mg cos theta into L by 2 plus mg sin theta L is equal to 0. mgl cancel, तो sin theta is equal to mu cos theta by 2. तो it is 2 sin theta by cos theta is equal to mu. तो mu आएगा आपका twice tan theta. This is the coefficient of friction between the two surfaces. You can also find this problem by using the equations, but it will become a little bit complex that way, और थोड़ा सा lengthy बनता है उससे. So if you have to solve the same problem by using work energy theorem, then this is the method. Question number 4. Now, question number 4. Simple question है. Here is an inclined plane. The angle of inclination here is 37. An object starts from rest from this point A, and it reaches here. Yeah. Let the velocity here is v. The length of this is 5 meter. You have to, question number A. Find speed. Find v. ये v निकालना है आपको. If surface is smooth. If surface is smooth. अब देखिए, surface is smooth means that there is no frictional force that is acting on the object. The only force that is doing work on this object is mg sin 37. ये वाला mg sin 37. असल में जो ग्रेविटेशनल फोर्स है दैट इज अ कंजर्वेटिव फोर्स. वर्क डन बाय ग्रेविटेशनल फोर्स आएगा mg इनटू दिस h. अब ये 5 का ये वाला कंपोनेंट 5 cos 37 और ये 5 sin 37, वो ये आएगा फिर से mg sin 37 into 5. So what is work done by this mg sin 37? That is positive because this force is downward, leg will be downward. So work done by gravitational force is change in kinetic energy. What is work done by gravitational force? mg sin 37 into 5 is change in kinetic energy. Final 1 by 2 mv square minus initially 0 because object starts from rest here. So this is the way to find the velocity. mm gets cancelled. बाकी substitute the value and get the answer. तो अगर आपको ये sin 37, इसका मैं एक ट्रायंगल दूंगा आपको. यहाँ पे ये 37 है. 37 डिग्री अगर ट्रायंगल होगा ऐसे राइट एंगल ट्रायंगल, तो ये 3 है, ये 4 है, ये 5 है. निकालिए आप sin 37 that is perpendicular by hypotenuse 3 by 5 cos 37 4 by 5 base by hypotenuse. So here you have to put substitute the value and you will get the answer. Part B इसी का find v dash. अब यहाँ पे v नहीं है, v dash है. If mu is equal to 0.25. Now coefficient of friction between the two surfaces is 0.25 and you have to find this velocity v dash at the bottom. तो सिंपल सा केस है. अब इसमें दो फोर्स एक्ट हो रहे हैं. एक तो mg sin 37, दूसरा फ्रिक्शनल फोर्स. ये यहाँ पे अगर एक तो mg sin 37, दूसरा फ्रिक्शनल फोर्स होगा. तो what is work done by this? वो सेम ग्रेविटेशनल फोर्स mg sin 37 into 5. Work done by frictional force minus mu mg cos 37 into 5 is equal to change in kinetic energy mv dash square. Substitute the value and get the answer. Theta and the angle of inclination is theta and object of mass m is pushed with initial velocity v naught. The coefficient of friction between the surface or between the two surfaces is mu. The velocity of the object decreases. At this point, the velocity of the object becomes 0. यहाँ पे इसकी velocity 0 बनती है. You have to find the distance traveled by the block before it stops. Distance find d. Find d. Distance traveled by particle object before it stops. And second, work done by frictional force. You have to find the work done by frictional force on this object. तो दो यहाँ पे देखिए. An object is pushed. Initial velocity v naught in this direction. The velocity of the object decreases. At this point becomes 0. The coefficient of friction between the two surfaces is mu. You have to find this d, distance before it stops, and also you have to find the work done by frictional force. अब देखिए यहाँ पे तो इस object पे दो फोर्स जो इसमें काम कर रहे हैं, एक तो फ्रिक्शनल फोर्स, ऑब्जेक्ट इज मूविंग इन अपवर्ड डायरेक्शन, तो फ्रिक्शनल फोर्स ऑब्जेक्ट पे डाउनवर्ड डायरेक्शन में, इस डायरेक्शन, और दूसरा यहां पे बनाइए आप, यहां पे जब ऑब्जेक्ट है तो फ्रिक्शनल फोर्स है डाउनवर्ड डायरेक्शन में, और दूसरा mg sin थीटा भी डाउनवर्ड डायरेक्शन में है, mg sin थीटा भी डाउनवर्ड डायरेक्शन और फ्रिक्शनल फोर्स भी डाउनवर्ड डायरेक्शन। लेकिन ऑब्जेक्ट की देखिए अब and displacement is in this direction. It means that the work done by this mg sin theta on the object is negative and work done by this frictional force on the object is negative. Now what is the work done by these two forces on the object? The work done by frictional force plus work done by gravity is change in kinetic energy. Final is 0, initial is so 0 minus 1 by 2 mv naught square. This is work energy theorem. Now what is work done by this frictional force? Work done by frictional force, पिछले केस में आपने देखा म्यू एम जी कॉस थीटा कहां से, तो यहां पे मैं डायरेक्ट लिखूं माइनस म्यू एम जी कॉस थीटा इनटू डी, दिस इज वर्क डन बाय फ्रिक्शनल फोर्स, प्लस वर्क डन बाय ग्रेविटी, तो माइनस एम जी साइन थीटा इनटू डी, बिकॉज़ एम जी साइन थीटा इज इन दिस डायरेक्शन, डी इज इन दिस डायरेक्शन, अपोजिट, तो माइनस आएगा, इज इक्वल टू माइनस 1 by 2 mv नॉट स्क्वायर, माइनस 1 by 2 mv नॉट स्क्वायर। अब माइनस से both sides multiplication करो इस इक्वेशन को, you multiply both sides this equation by minus and m gets cancelled, तो ये बनेगा mu g d cos theta plus g d sin theta is equal to b naught square by 2। अब d यहाँ पे कॉमन करो, तो d जब कॉमन, d g भी कॉमन करो, तो ये आएगा mu cos theta plus sin theta is equal to v naught square by 2, तो d आएगा आपका v naught square by 2 g mu cos theta plus sin theta, this is distance before it stops, this is d, the distance traveled by the block before it stops। Now you have to find the work done by frictional force, तो work done by frictional force कहां से मिलेगा आपको, देखो this is the work done by frictional force on the block minus mu mg cos theta into d, तो वर्क डन बाय फ्रिक्शनल फोर्स आएगा माइनस म्यू एम जी कॉस थीटा इनटू डी, डी का वैल्यू क्या है, सब्स्टिट्यूट दैट वैल्यू हियर, तो बनेगा वी नॉट स्क्वायर बाय ट्वाइस जी म्यू कॉस थीटा प्लस साइन थीटा, दिस इज वर्क डन बाय फ्रिक्शनल फोर्स, this work done by frictional force। You can also divide numerator and denominator by cos theta, तो ये बनेगा minus mu mg v naught square by 2g mu plus tan theta। If you divide the numerator and denominator by cos theta, वो आप खुद कर लेना अपने अपने घरों में, work done, this is work done by frictional force। Now question number 6, question number 6, question number 6, an object starts from rest from point A, means यहाँ पे इसकी initial velocity 0 है, the angle of inclination is theta and this height is given h, the object starts from this point and finally it stops here, this point where it stops is distance d away from this point, the coefficient of friction between the surface of between the two surfaces mu, and between this horizontal surface and this object is also mu। Now question is work done, find work done by frictional force, find work done by frictional force। Question देखिए फिर से, this is a surface like this, an object starts from here and finally the object stops here, the point where it stops is at distance d from this point, the coefficient of friction between this surface and the surface of object is mu, and between this horizontal surface and the surface of object is mu। You have to find the work done by frictional force। अब देखिए apply work energy theorem, work done by frictional force plus work done by gravitational force is equal to change in kinetic energy। यहाँ पे stop हो रहा है तो final 0, यहाँ से start तो initial 0, तो that is 0। What is work done by frictional force? अब देखिए frictional force, first of all I will find the work done by frictional force on the object over this distance, and that you know वो आएगा minus mu mg cos theta into distance, into ये वाली distance। अब let this distance be L, तो L का ये वाला कंपोनेंट आएगा cos और ये आएगा sin। तो इसका मतलब हुआ ये जो h है h is equal to L sin theta और L आएगा आपका h by sin theta। L is equal to h by sin theta। तो डिस्टेंस के बदले में लिखो h by sin theta। This is work done by frictional force over this distance. Now we will find the work done by frictional force over this distance. That is simply minus mu mgd, because frictional force in this, displacement in this. So minus mu mgd. This is work done by frictional force over this distance. Plus work done by gravity. अब देखिए, work done by gravitational force over this distance on the object is zero, because mg in downward direction, that is perpendicular to this distance. The gravitational force, the work done by gravitational force over this distance is simply mgh, mgh या mg sin theta into h by sin theta, वो फिर से mgh ही आएगा, plus mgh is equal to 0. तो mg cancel, तो क्या बनेगा ये minus h cos by sin cot theta minus mu d plus h is equal to 0. तो h को इस इक्वेशन और इस यहां से और यहां से मैं h कॉमन करूं तो ये बनेगा h1 माइनस यहाँ पे म्यू डी है, म्यू 1 माइनस म्यू cot थीटा इज इक्वल टू म्यू डी, तो h आएगा आपका म्यू डी बाय 1 माइनस म्यू cot थीटा। बट यू हैव टू फाइंड द वर्क डन बाय फ्रिक्शनल फोर्स। तो आप इस h का देखिए, वर्क डन बाय फ्रिक्शनल फोर्स ऑन द ऑब्जेक्ट इज दिस। नाउ यू हैव टू सबस्टिट्यूट the value of h in this here, so then you will get the answer, but it will become a little bit complex. Why not this work done by, कैसे हम इसको ऐसे भी निकाल सकते हैं, देखिए as you know work done by frictional force plus work done by gravity is equal to 0. तो इस इक्वेशन से मुझे work done by frictional force minus work done by gravity, तो what is the work done by gravity, that is minus mgh, तो minus mg, अब h का वैल्यू कितना है आपके यहाँ पे mu d by 1 minus mu cot theta. This is work done by frictional force or this whole distance. Now next question, question number 7. Question number 7. This is work done by frictional force over this distance. Minus mg mu d by 1 minus mu cot theta. Question number 7. Question number 7. Here is a ground and here is a tower of height h1 और यहाँ से एक object launch हो रहा है with velocity v1 and this object is launched from this point with velocity v1. At this point the velocity of the object becomes v2 और this object इसकी height जो है from the ground, that's h2. Now you have to find the work done by air resistance. Find work done by air resistance. By air resistance on object. Find work done by air resistance on object. अब देखिए, एक तो इसमें gravitational force है, an object is going from this point to this point, और दूसरा air resistance भी है. And you have to find the work done by air resistance on this object over this distance. तो first of all, यहाँ से लेके यहाँ तक distance कितनी होगी? यहाँ से लेके यहाँ तक h2 है, यहाँ से लेके यहाँ तक h1 है, तो यहाँ से लेके यहाँ तक होगा h2 minus h1. What is work done by gravity over this distance? तो mg in downward direction, h2 minus h1 upward. तो work done by gravitational force plus work done by air resistance, change in kinetic energy, final kinetic energy 1 by 2 m v2 square minus v1 square. So what is work done by gravity? Minus mg h2 minus h1 plus work done by air resistance is equal to 1 by 2 m v2 square minus v1 square. तो work done by air resistance आएगा आपका 1 by 2 m v2 square minus v1 square plus mg h2 minus h1. This is work done by air resistance. This is question number 8. A ball of mass m is projected in upward direction with velocity 10 meters per second. The velocity of the object decreases. At the highest point, the velocity of the object becomes 0. So and the air resistance, and the resistance that is acting on this ball is R in downward direction. Then it falls and it hits the ground with velocity 8 meters per second. तो यहाँ से लेके यहाँ तक air resistance फिर से R ही होता है, लेकिन in upward direction. You have to find the maximum height attained by the ball. Find h. Find maximum height attained by the ball. First of all, I will apply work energy theorem on this object from over this distance. So, what are the forces that are acting on this object? एक तो mg in downward direction, दूसरा r भी downward direction भी. तो work done, दो forces, एक तो resistance, work done by resistance plus work done by gravity is change in kinetic energy. Final kinetic energy is 0 minus initial 1 by 2 m. 10 square, that is 100. So what is work done by A resistance? Resistance is downward, H is upward. So minus RH plus what is work done by gravity? Mg downward, H upward. So minus mgh is equal to minus 50m. This is equation first. Yeah, minus cancel karo to RH plus mgh is equal to 50m. This is equation first. Now in second case, apply work energy theorem. So what is work done by gravity? That is simply in this case, यहाँ से लेके यहाँ तक mgh. This is work done by gravity, positive because mg downward, h downward. What is work done by E? Resistance is upward, h is downward. So work done by this resistance is negative. So minus RH. Change in kinetic energy. Final. That is 1 by 2 m. 8 square 64 minus यहाँ पे 0. So that is this. So ये इक्वेशन बनेगी mgh minus rh is equal to 32m. This is equation second. Add these two equations. तो जब आप ऐड करोगे rh plus ये कैंसिल होगा because plus minus mgh twice mgh is equal to 82m. mm gets cancelled. h is equal to 82 by 2 into g. Take g here 10. तो 82 by 20. तो ये आएगा 4.1 meter. This is the maximum height attained by the ball. This is question number 8. Now question number 9. Question number 9. Question number 9. Question number 9. Here are two planks. This is plank 1 and this is plank 2. A bullet hits the plank 1 with velocity v and it comes out from the first plank with velocity, और यहाँ पे जो इसकी velocity होती है that is 4v by 5 and it hits and it penetrates the second plank with the same velocity, so 4v by 5 and then it just penetrates through. Just penetrates through means जब ये बाहर आता है तो यहाँ पे इसकी velocity 0 होती है. Let the thickness of this plank be T1 and the thickness of this plank be T2. We have to find the ratio of thickness. Find T1 by T2. तो resistance यहाँ पे भी R है और यहाँ भी R है. The resistance offered by these planks on the bullet, that is R, in same in both the cases. You have to find a ratio of thickness. A bullet penetrates plank 1 with velocity v1 and it leaves with velocity 4v by 5. It penetrates second plank with the same velocity 4v by 5 and then यहाँ पे इसकी velocity 0 होती है. Let the thickness of this plank be T1 and this T2. You have to find the ratio of thickness. By applying work energy theorem over this distance, so what is the force that is acting on the bullet? That is this resistance. So and this resistance is doing negative work because this is acting on bullet in this direction, like this. And bullet and this distance bullet is going in forward direction. So work done by this resistance is minus RT1 is equal to change in kinetic energy. Let the mass of the bullet be m. So 1 by 2 m final. तो इसका स्क्वायर तो बनेगा 16 v स्क्वायर by 25 initial. तो v स्क्वायर तो ये आएगा minus RT1 is equal to 1 by 2 m. तो 16 v square minus 25 v square, so that is minus 9 v square by 25. Minus gets cancelled, तो RT1 आया आपका 1 by 2 m into 9 v square by 25. This is equation first. Now apply work energy theorem over this distance T2. तो यहाँ पे भी work done by this resistance is negative, तो ये आएगा minus RT2 is equal to 1 by 2 m final speed, that is 0 minus initial square, so that is 16 v square by 25. So minus gets cancelled, so RT2 is equal to 1 by 2 m 16 v square by 25. This is equation first, this is equation second. Now divide the two. Divide the two equations. तो क्या बनेगा? RT1 by RT2 is equal to 9mv square by 25 into 2. जब आप डिवाइड करोगे तो ये वाला ऊपर जाएगा, तो बनेगा 25 into 2 by 25 into 2, 16 mv square. 16 mv, this gets cancelled. mv square gets cancelled. R gets cancelled. It means that T1 by T2 is 9 by 60. This is the ratio of thickness. The force versus displacement, question number 10. The force versus displacement graph of a 500 gram particle starting from rest. So starting from rest is shown in figure. The velocity of the particle at x equal to 8 meter. This is the force and displacement graph of a particle that is starting from rest. Starting from rest means its initial velocity is 0. Is shown in figure. You have to find the velocity of the particle at x equal to 8 meter. You have to find when particle reaches at x equal to 8 meter. You have to find the velocity of the particle there. So simply, first of all, I will find the work done. What is the work done by the force? As you know, आपने पढ़ा होगा, work done is the area under force and displacement curve. This is the work done. So it means that work done जो आएगा, that is the area of this triangle. 1 by 2, base is 8, altitude 16. So 4, that is 64 joule. This is work done. As you know, according to work energy theorem, work done by all force equal to change in kinetic energy. So therefore, 64 is equal to 1 by 2 m v square. So this v is the velocity at x equal to 8 meter. So 1 by 2 m v square minus u square. That u is the initial velocity of the particle. And x equal to 0, and that is given, and that is equal to starting from rest, means its initial velocity is 0. So लिखूंगा ही नहीं. So 64 is equal to 1 by 2. What is mass of the particle? That is given 500 gram. तो अगर किलोग्राम में कन्वर्ट करेंगे तो 500 divided by 1000, that is 1 by 2 into v square. तो 2 2s are 4, 4 into 64 is equal to v square. Square के बदले रूट आएगा तो ये बनेगा 2 into 8, that is 16 meter per second. This is the velocity of the particle at x equal to 8 meter. ये लिखा था. Question number 11. Question number 11. The force acting on a particle of mass 3 kg. The force acting on a particle of mass 3 kg produces displacement x is equal to t cube by 3. T cube by 3. Find work done by force. Find work done by force in first 2 seconds. You have to find the work done by force in 2 seconds. So, as you know, according to work energy theorem, work done by force, work done by all force equal to change in kinetic energy. So, if you have to find the work done, you have to find this change in kinetic energy. So, what is this V? Here V is the velocity of the particle at t is equal to 2 seconds. First of all, we have to give that display x is equal to t cube by 3. First of all, I will differentiate this equation with respect to time, and there we get the velocity. So therefore, x इसकी differentiation v आएगा dx by dt. So that is t square. 3t square by 3, 3 cancel, that's t square. Now, this v is the velocity at t is equal to 2 seconds. Now, what is the velocity at t is equal to 2 seconds? That is equal to 2 2s are 4 meter per second. So 1 by 2 m, that is given 3 v square, 4 square, that is 16 minus u. U is the velocity of the particle at t is equal to 0 second. At t is equal to 0 second, v आएगा 0, it means that v 0 आएगा आपका 0. तो 0. So 2 1s are 2 8s are 8 3s are 24 joule. This is the work done by the force. Or you can also find the work done by using this method. As you know, work is equal to f dx. So f के बदले मैं लिख सकता हूँ mass acceleration dx. I can also find work is equal to f dx m a dx. तो mass is constant, ये बाहर आएगा m, तो ये बनेगा a dx mass acceleration. अब acceleration आप देखिए v is equal to v क्या है आपका t square. अब अगर मैं इस इक्वेशन को v is equal to t square इसको डिफरेंशिएट करूं dv by dt तो ये आएगा 2t. तो substitute the value of acceleration here 2t. तो dx तो dx by dt आता है t स्क्वायर, तो dx आएगा t स्क्वायर dt, तो m mass is given, that is 3 2s are 6, इंटीग्रेशन ऑफ t क्यूब dt, लिमिट्स लगेंगे 0 से लेके 2 तक, तो 6 ये बनेगा इसकी इंटीग्रेशन t raised power 4 by 4 0 से लेके 2 तक, तो 6 by 4 into 2 2s are 4 2s are 8 2s are 16 4 1s are 4 4s are 6 4s are 24 Joe. You can also find this method. 12. Two blocks are connected by a string. They are released from rest. When block of mass m1 is moving towards right through distance L, find common speed if coefficient of friction between m and surface is mu. The question is simple. The block of mass m1 is moving towards right through a distance L. तो इसका मतलब ये ब्लॉक आगे जाएगा L, तो ये ब्लॉक नीचे आएगा L. तो इसका मतलब अगर इस ब्लॉक की स्पीड v है, तो इस ब्लॉक की भी स्पीड क्या होगी v, तो इसका मतलब this system will move with a common speed and let that common speed be v. You have to find this common speed, but you have to remember that the system, two blocks are connected by, they are released from rest, means both blocks are starting from rest. It means that initial kinetic energy of both the blocks is 0, or initial kinetic energy of the system is 0. Now you have to find the common speed of this system, of these two blocks. The forces that are acting on this block m2 is m2g in downward direction, और दूसरा tension T upward. तो यहाँ पे tension T, m1g downward and normal direction वो बनाऊंगा नहीं, work done is 0. तो and तीसरा और दूसरा force पे frictional force है. अब देखिए m1g भी है, normal direction है. Since this block is moving through a distance towards in this direction, the work done by m1g and normal direction is 0. Now अब देखिए, अब अगर इस टेंशन की बात करेंगे, आपने लॉज ऑफ मोशन में पढ़ा होगा, the net work done, the total work done by tension on a system of blocks, the total work done by tension on a system of blocks connected by inextensible massless string is equal to 0. But I will involve here यहाँ पे ताकि आपको समझ में आए. तो what is the work done by this m2g on this block? This block is moving in downward direction through a distance L. So work done by gravitational force on this block is m2gl. What is work done by tension? T in upward, L in downward, so minus TL. Plus, what is work done by this T on this block pointing up in same direction? Now, what is work done by this frictional force? It's in this direction. So frictional force यहाँ पे minus mu m1g into L. This is work done by the force is equal to change in kinetic energy. अब देखिए, since both the blocks are moving with common speed, so what is the final kinetic energy of this system? Final kinetic energy of the system is 1 by 2 m1 plus m2 v square. This is the final kinetic energy of the system minus initial kinetic energy of the system. Both blocks are starting from rest. तो initial kinetic energy of the system is 0, minus TL plus TL to 0. तो वही तो मैं बोल रहा था, the total work done by tension on a system of blocks is equal to 0. तो m2, तो gl कॉमन कीजिए इसमें, तो ये बनेगा gl. तो m2 minus mu m1, 2 से multiplication, तो ये divide by m1 plus m2 v square है, तो इसके बदले root is equal to v. This is the speed of the system. V is equal to root of 2. This shows two blocks. This is one block, this is second block. Of masses 2m and m. इसका mass 2m, इसका m respectively. The coefficient of friction between the block of mass 2m and horizontal plane is mu. The coefficient of friction between the two surfaces is mu. The system is released from rest. System is released from rest means the initial kinetic energy of the system is 0, or initial kinetic energy of the system is 0. Find the velocity of the block of mass m. You have to find the velocity of this block having mass m. When the block of mass 2m has moved a distance s towards right. When this block of mass 2m is moving a distance s towards right, you have to find the velocity of this block having mass m. तो आपने लॉज ऑफ मोशन में पढ़ा होगा, if this block moves a distance s in forward direction, तो ये नीचे जाएगा, ये वाला ब्लॉक s by 2. तो इसका मतलब वो अगर इसकी वेलोसिटी v है, तो इसकी वेलोसिटी होगी v by 2 in downward direction. तो बस अप्लाई करें एनर्जी थ्योरम, you will find the velocity of the block of mass m. तो अब तो मैं टेंशन नहीं बनाऊंगा because you know the total work done by the tension on the system of blocks is 0. तो एक तो gravitational force इस पे that is mg. What is work done by that mg? mg in downward direction. तो mg into distance that is s by 2. Both are in same direction तो mg s by 2. इस पे तो एक frictional force है. Frictional force. So how much work frictional force in this direction? Displacement s in this direction. So work done by frictional force mu 2mg into s. This is work done by frictional force. Tension का तो total work done 0 आएगा, वो बना होगा in normal reaction mg का 0 is equal to change in kinetic energy. Since देखिए, what is the final kinetic energy of the system? That is the kinetic energy of this block plus final kinetic energy of this block. So final kinetic energy जो system की आएगी that is 1 by 2 mass of this block m. What is the speed of this block? V square by 4. This is kinetic energy of this block plus इसकी kinetic energy 1 by 2 2m v square. What is this is final kinetic energy of the system. What is the initial kinetic energy of the system? Since the system is starting from rest, so initial kinetic energy is 0. But this is the equation. Solve this equation, you will get the value of v. There you get the value of v. But remember one thing, that v is the velocity of the block having mass 2m. But you have to find the velocity of this block having mass m, and that is v by 2. So when you solve this, you will get the value of v. Then you have to divide that v by 2, and you will get the speed of this block having mass m. So ये आप घर में कर लेना. v by 2 is the speed of this particle. Now question number 14. Question number 14. Question number 14. Here is a block of mass 1 kg. Block of mass 1 kg. It starts from rest at this point A. The height of this is 1 meter from ground, from this surface, and it finally stops here. And this height is 0.8 meter. The surface is rough. This surface is rough, and you have to find the work done by frictional force. Find work done by frictional force. अब देखिए आप, जो gravitational force है, gravitational force is a conservative force. So it means that work done by conservative force depends only on initial position and final position of the object, and not on the path. तो इसका मतलब हुआ, यहाँ पे अगर particle है कोई, इसका mass अगर m है, let this particle is at height h from the surface of the earth. Since if the force that is acting on the particle is mg in downward direction, gravitational force, let this particle be taken from point A to point B, and this height is h dash. तो अब अगर मैं बोलूं what is the work done by gravity in moving a particle from point A to point B, the work done by gravity in moving a particle from point A to point B is minus mg h dash. This is work done by gravity. As gravitational force is a conservative force, it depends only on initial and final position. तो आप अगर particle को यहाँ से इस पाथ से लोगे तो भी work done minus mgh आएगा, अगर ऐसे लोगे आप तब भी minus mgh ही आएगा, because gravitational force is a conservative force, it does not depend on path. अगर ऐसे लोगे तब भी minus mgh ही आएगा. And दूसरा condition है conservative force के लिए, the work done by conservative force over a closed path is always equal to 0. तो इसका मतलब वो अगर मैंने पार्टिकल को पहले A से लेके B तक लिया इस पाथ से, फिर B से लेके A तक वापस, तो what is work done by gravitational force in that case? The work done by gravitational force in that case is 0, because gravitational force is a conservative force. The work done by conservative force for a round trip is always equal to 0. So work done by conservative force जो होता है over a round trip, that is closed path, F dot dr, that is equal to 0. और हमेशा याद रखना, अब देखिए कंजर्वेटिव फोर्स कौन कौन सा है? एक तो ग्रेविटेशनल फोर्स है, इलेक्ट्रोस्टैटिक फोर्स, सुप्रीम फोर्स, these are all conservative forces. And हमेशा याद रखना, work done by conservative force is always equal to the negative change in potential energy. Work done by conservative force is equal to the negative change in potential energy. Basically जो potential energy है, potential energy is defined only for conservative forces. Potential energy is different only for conservative force, and work done by conservative force equal to the negative change in potential energy. So let me analyze this equation from this thing from this basic example. So, देखिए, what is when a particle is moving from point A to point B? What is work done by gravity in moving a particle from A to B? Work done by gravity in moving a particle from A to B is minus mg h dash. Now, what is the potential energy at point B? When a particle of mass m is, the potential energy of the particle at point B is simply mg h plus h dash. This is potential energy of the particle at point B. What is potential energy of the particle at point A? That is simply mgh. What is change in potential energy? UB minus UA is the change in potential energy, delta U. That is equal to mgh plus h dash minus mgh. This gets cancelled. It is minus mg. What is change in potential energy? So change in potential energy I get delta U. That is potential energy at point B. So what is potential energy at point B? That is mgh plus mgh dash. What is potential energy at point A? That is minus mgh. So this and this gets cancelled. So potential energy at point the change in potential energy is simply mgh dash. This is equal to delta U. Now, what is work done by gravitational force when a particle is moving from point A to point B? That is minus mgh. So work done by conservative force, work done by gravitational force is equal to negative mgh dash. What is this mgh dash? This is the change in potential energy between point A and B. So यही तो मैं बोल रहा था, work done by conservative force always equal to negative change in potential energy. आगे this ये बहुत बड़ा टॉपिक है, लेकिन यहाँ पे थोड़ा सा काम आएगा. तो हमेशा याद रखना, the potential energy is defined for conservative force. Work done by conservative force is always equal to negative change in potential energy. Whenever you are doing work against conservative force, the work gets stored in the body in the form of potential energy. Work done gets stored in the form of potential energy. So you have to find here the work done by frictional force. So normal reaction का work zero है. The two forces that are doing work, एक तो work done by frictional force plus work done by gravitational force, change in kinetic energy. यहाँ भी zero velocity, यहाँ भी zero, तो this is zero. Work done by frictional force is negative of work done by gravity. As gravitational force is a conservative force, so work done by gravitational force is negative change in potential energy. Minus minus plus delta U. So change in final potential energy is this: mass g height minus mass g height. So 10 into 8 by 10 minus 10. So 10 can cancel. So minus 2 joule is the work done by frictional force. Question number 15. Question number 15. Here's a smooth curved surface area, and then there is a rough horizontal surface. Then again smooth curved surface area. An object starts from here. The height of this is h, where it starts. And in fact, this object starts from here, means it starts from here. Its initial velocity is 0. The coefficient of friction between the two surfaces is mu, and the length of this horizontal surface is L. And finally, the object moves on this smooth curved surface and reaches here. Let this h be, let the height be h dash. You have to find this h dash. तो अब सोचने वाली बात है, जब पार्टिकल यहाँ से आया, some energy is lost here against friction. तो इसका मतलब ये जो height होगी, ये कम होगी as compared to this height, because some energy is lost here against this frictional force. Against some work is lost. Some energy is lost here. तो we have to find this h dash. तो कैसे निकालूं मैं? तो gravitational force है, तो दो ही force तो इस पे काम करें, एक तो frictional force, दूसरा gravitational force. Work done by frictional force plus work done by gravitational force, change in kinetic energy. Finally it stops here. Initially it was at rest, so 0. What is work done by frictional force? Frictional force is doing work only over this length. So what is that work? Minus mu mgl plus what is work done by gravity? तो ये what is this? ये height कितनी होगी? This is h minus h dash. तो work done by gravity is mgh minus h dash is equal to 0. तो mgh minus h dash is equal to mu mgl. mg gets cancelled. H minus h dash is equal to mu l.
तो h माइनस म्यू l इज इक्वल टू h डैश, दिस इज द हाइट, ये वाली हाइट, यही तो निकालनी है हमें। ओके, अल्लाह हाफ़िज़।